Doing the topic differentiation of logarithm functions. So before we begin, let's start with a starter activity. So this is an activity on how to simplify logarithm function. Okay, time's up. Let's see, we can simplify this one. Let's hope that you get this correct. So basically, to do this, you will apply a few of the rules. You will have the power rule, the chain, not the chain rule, the multiplication rule and the division rule there. Okay, so what we do here is we have to move the two element 4 to using the power rule. So if it's plus, we use the multiplication, and minus is division. So ln 4 squared times 3 over 6, and your answer should be ln 8. Okay, so moving on, so what we are going to do for this lesson is, the objective is we will be able to differentiate logarithm functions by using the chain rule or product rule or quotient rule. And also we will be able to find the value of gradient by differentiating logarithm function. So the moral integration will be a little progress each day adds up to big results. So basically for this topic, so what we've been doing is we started with how to differentiate simple algebraic expressions. Then we were able to use a chain rule to differentiate, then the product rule and the quotient rule, and now we are using all those to differentiate this topic, which is logarithm function. So there are some rules of logarithm functions which you need to review, which is the power rule, the multiplication rule, the division rule, and the change of base rule. So let's how to find the derivative of logarithm function. So to find, basically you're using the chain rule here. So if we are to differentiate any log function, and taking note that we can only differentiate log to the base e. That's the reason why we can only have ln log. Okay. So what we do is whatever function we have, we just put 1 over the function, multiply by the derivative. So then this is the most general rule for logarithm function here. Then we multiply, then you get the answer. So if we differentiate log x, we actually get 1 over x. Okay, so because if it's just x, the function, so 1 over x, and if we differentiate x, becomes 1. So the answer is still 1 over x. For log ax plus b, so this one, we basically have 1 over ax plus b times the derivative. In this case, is just a, because ax, we differentiate, we get a, and b is a constant number, so b becomes 0 there. Okay, moving on. So let's try the first example. So how do we differentiate ln 8x? So it's just going to be one same function. So if it's 8x, so it's 1 over 8x. And now we're going to differentiate 8x to get 8. So if we simplify them, our answer is just 1 over x. Moving on. So for this one, it's going to be similar. Or give yourself a minute to actually differentiate this. This will take you actually like 15 seconds. Okay, so for this one, how you differentiate? Basically, you have 1 over 5x minus 7. If you differentiate 5x minus 7, you only get 5. So answer is 5 over 5x minus 7. Okay, the third one. So if we have log 2x squared plus 5, so in this case, you will only similar 1 over 2x squared plus 5 and differentiate 2x squared, you get 4x. So your final answer is 4x over 2x squared plus 5. Okay, moving on. So this one will have an additional step, which will make it easier. You will have to use the power rule, okay? Because of the cube there, right? So when we're using the power rule, so it becomes 3. The power 3 moves to the front, which gives us 3 times log 7 minus 2x. So now 3 there is just like a number there. So it's a constant. So all we have to do is to multiply them. So our answer will be 3 stays there. We do not remove the 3, yeah? So we have ln the function, so 1 over 7 minus 2x multiplied by negative 2. So take note, it's a negative 2x, so if we differentiate, it's negative 2. So final answer is negative 6 over 7 minus 2x. Okay, then we have the next example. So this involves trigonometric function. Okay, so same thing. How do we differentiate them? So we have 1 over 1 plus sine x multiplied by cos x, because when we differentiate 1, it becomes 0, sine x becomes cos x. Final answer, cos x over 1 plus sine x. Okay, moving on. So now for this one, we have log. Okay, this is a slightly more. So first of all, we have to use the rules of indices. What does square root mean? Okay, square root means we have to change to the power half. Again, this will be easier if we use the power rule. So we move the half to the front and then we differentiate them. Your answer should be 1 over 2x minus 20. If you do not expand this, it's still fine. The answer is correct. Okay, moving on. So we for this one, you have to use the, because it's a product of two functions, you have to use the product rule. Okay, product rule. You have to differentiate both, and then using the rule, which is v over v du dx plus u dv dx. Okay, usually this will be good enough without even simplifying, but if you want to simplify, just one more step, that's good enough. Okay, the answer is 30x power 5 log 2x plus 5x power 5. Moving on, so for this one, this is a quotient of two functions, so we have to use the quotient rule. Okay, so same thing, we have to use the quotient rule. So we have ln, let u equals to ln x, let v equals to 3x. Okay, you differentiate them. So using the rule, you can choose to simplify further. If not, you can just keep your answer that way. It's no problem with that. Okay, you can still solve it. I mean, simplify, you can solve it, sorry. So simplify 3 minus 3 log x over 9x squared. Okay, so for this one, this will require you to basically, it makes it easier, so we are going to use some rules of logarithm function here. Okay, so first of all, part A, you just have to show this has nothing to do with the differentiation, but rather than you trying to use the skills of that. Okay. Okay, for this one, so we have to use the division rule. So we minus, change the power, and using the power rule, then we are able to show that. Next, part B. So Now for this one, for the second objective where we are asked to find the value of the gradient. So gradient in this case is dy over dx. So we have to find when x equals to 1. So now let's you should try to differentiate. Okay, when you differentiate this, because there's a function y there, so we have to find dy dx. So what we do, same thing, is two different terms, so we don't need to use the product rule here. Okay, so you should get half times, when you differentiate half log 2x minus 1, you get half times 1 over 2x minus 1 times 2. That's for the first term, and the second one will be, because there's a minus there, we just put that, so 1 over x squared plus 1 multiplied by the 2x there. So if you simplify everything together, I do not recommend you to simplify further. That's it. Then substitute the value of 1, and then you get your gradient. In this case, your gradient is 0. Okay, it's possible to have gradient 0 because we can have positive gradient, negative gradient, and also 0 gradient is possible. All right, moving on to the last one. Okay, so we have y equals to log of 5x minus 2 to the base 2. So for this one, it's just using the rules of logarithm as well. So how do you do this one? Okay, so basically this one you're going to be using the change of base rule. Okay, because we cannot differentiate log to the base 2, we have to change it to something ln2. That's the reason why they want us to prove first, to show. Okay, so this is going to be just using the change of base rule. Since ln is base e, so log to the base e 5x minus 2 over log of 2 to the base e, and your answer will be as shown there. Just one step only. Okay, so for the next one, this is the last one here. So we are going to find the exact value. So exact value means no decimal place. Okay, either in surds or in fractions there. So you have to differentiate. So think about 1 over ln2. ln2 is just a number, so there's nothing to differentiate there. Okay, so we just 1 over ln2 stays 1 over 5x minus 2 times 5 when we differentiate log 5x minus 2. Then when we find the value of the gradient, your final answer is 5 over 8 ln2. Okay, so that's the end of the lesson. Okay, so please take a minute to talk about what you have learned, and also tell us 3 things which you have learned in this lesson. So that's all for this lesson. Thank you, everyone.